Section 8.4a, working with logs. All right, let's do this. So we're going to rewrite the equation in exponential form. So remember, the base here is your base. And then the value that this equals is your power, or exponent. And then what's sitting right after the base is what that's supposed to equal. And 2 to the third does equal 8. All these are going to be equivalent. It's just learning how to rewrite it, learning how to understand what log notation means versus exponential form. So this base is 5, the power is 2, and that should equal 25. The base is 3, the power is 3, should equal 27. The base is 9, the power is 1/2, which means square root, and that equals 3. The base is 5, the power is -1, and that equals 1/5, right? If you think about that as a trader, moving the base with the negative exponent to the other side of the fraction bar. 2 to the -3rd power is 1/8, which makes sense because this is equivalent to 1/2 to the +3, and 1/2 to the +3 is 1/8. Grab your calculator. Let's take the natural log of the square root of 3. Should get 0.549. That got spaced out kind of funny. The log of 11.5 is 1.061, and the natural log of 2/3 is -0.405. If you're like, why did that just happen? What just happened here? Folks, by the way, you can rewrite this as the natural log of square root of 3 equals what? Equals x. You can write an x there to show the equals of what. And you just found the what. But if you do what we just did in 1 through 6 and rewrite this in exponential form, when it's ln or natural log, that means your base is e. So really it was e to the x equals square root of 3, which is like 1.7 something something something. We just figured that out. If you take e to the 0.54, you get the square root of 3. Our base is 10 here. If you don't see a number next to the log, a subscript, that's 10. So the base is 10, the power is x. 10 to the what equals 11.5. That's the what. 10 to that tiny number, 1.061. And then here, again, our base is e, so e to the what equals 2/3 or 0.666. Repeating, if you raise e to that negative number, that will do it. Remember, when you raise a number to a negative number, it does the reciprocal of it. So it makes it a small value, typically, depending on the situation. All right, let's move. Oh no, I added a page. What kind of clicking are you doing here? Evaluate the expression without using a calculator. Yeah, we can do this without a calculator. We want to know what log base 2 4 equals. Oops, so we want to know what this equals. So 2 to the what equals 4. Well, x has to be 2 because 2 squared equals 4. Set these all equal to x. So now if we transition this to exponential form, it's 2 to the what equals 32. That has to be 5. 8 to the what equals 64. That'd have to be 2. Let's keep on writing what's or x's or unknowns after these. 3 to the what equals 27. That would have to be 3. 4 to the what equals 1. That'd be 0, folks. 2 to the what equals 1/2. It'd be a -1 because 2 to the -1, you have to move that to the base and the negative exponent to the opposite side of the fraction bar. It becomes 2 to the +1 on the bottom, which simplifies just as plain old 1/2. 2 to the what equals 8, so x has to equal 3. 5 to the what equals 5, it has to be 1. And then 6 to the what, ooh, I put a 0 there. 6 to the what equals 1. It has to be 0. there we go.